Dear audience, today I will talk about NTP Relay. The reason why I made this video is because one of our customers asked us to implement a user-embedded controller to request network time from a NTP server inside their private network. Because the embedded controller and the NTP server are not in the same network, so we need something in between to do the relay. This NTP Relay is one of the applications of Network Address Translation, NAT. So let's get started. Here is our setup. Over there is a SIG MSC800 embedded system, which is a controller of the whole DWS system. It is connected to this switch over this black Ethernet cable, and then on the same switch there's a blue Ethernet cable, which is further connected to this laptop. If we open the SOPAS engineering tool, it will scan all devices in the network automatically. MSC800 is our target device. Double-click to add it to the workspace. It may take a while to load the device settings. Click Login to log in as a service user. If you don't know the password, please contact our support team. Now navigate to the service folder, and you can see system status here. Here, the date is incorrect. We will use NTP settings in system to enable getting time from network server. NTP settings is over here. Enable time client. You need to put the server address over time server IP addresses and read through Ethernet. There are 3 Ethernet ports. We are using number 1. In this tutorial, we are using the local laptop as a relay to get the embedded system to access to the Google NTP server. Now let's use command ipconfig all to see the IP address of the local laptop. Here's the IP address of the laptop in the local network. Put it into the server IP address and save the setting. To make sure the embedded controller could talk to the laptop, I use a ping function in the network interface IOs and then Ethernet. And then ping Google NTP server from my laptop. As you can see, we got a response from Google NTP server. All good. Let's have a trial whether we can access Google NTP server directly from the embedded controller. to the IP address here. And then ping. As you can see, the light is gray. It means the embedded controller cannot talk to the Google NTP directly. Save the settings. Up to now, we have done the settings in MSA800 embedded controller. The next step is to write a Python script which forward request from the embedded controller through my laptop and then to the Google NTP server. Open up a VS Code and create a Python file called NTP Relay.py. First thing, import the socket library. Next, create some constant configuration data, like NTP server address. Which was that address? The Google NTP server should be this one. Copy and paste here. Make sure it is enclosed in double quotation as a string. Next is a port number of NTP server. NTP is always transmitted through port 123. And the local, which local IP address we are listening to. Here we can use 0.0.0.0, which means listen to all local IP addresses. Alternatively, you can specify a specific IP address, like you just want to listen to the local area network. You can find it from IP config all, which is this one. Next step is to initialize two sockets. One, talk to the NTP server over the internet. The other one, listen to the local requests in the local area network. I call the socket which talks to the NTP server as upper link socket, and use a socket.socket constructor to create this instance. The socket constructor takes some parameters. The first one is address family. AP internet means IPv4. And the socket kind, here I use socket DGRAM, which is UDP, because NTP is transmitted over UDP. For other protocols, for other TCP-based protocols, please use a socket stream instead. Add some comment to remember me what I'm doing. Step is to create another socket which listens to local requests. I call this a downlink socket. Again, use a socket.socket constructor. I can just copy this one. It's exactly the same thing. In order to listen to the specific port, I use a band function, which takes a pair, Python pair, IP address, and a port number. Here I put listen addresses and the NTP port. We have done initializations. Let's add some print function for debug. After initialization, let's have our main loop, which is a endless loop. Let's use while true. After this main loop, let's do some cleaning up. We need to close everything, close every socket created before terminate this program. In the main loop, the first thing is to listen to the local client's request. So let's use receive. Not sure which function should I use. Just ICV. Let's see. The output is byte, which is data, and ICV from with the IP address who sends the request. So I think I should use this one. The first thing is buffer size. What's the buffer size for NTP? Let's find out. Let's open up Wireshark. Wi-Fi is a channel my laptop access to the internet. So let's watch this channel. In order to create a NTP request package, let's use this tool, NTP Checker. You can download online. Let's put Google NTP's IP address, which is this guy. Copy and test. We got a response from Google. Let's close this and stop watching. Put NTP. As you can see, here are two NTP package. One is request, one is response. Both are 90 bytes long. Let's put 90 as maybe some tolerance, 128 as buffer size. The socket received from has two return values. One is the data which received, and who sent this data, which is let's call it what? Downlink request address, I guess. Put a print function here for debugging. we have handled the request from clients in the local area network. The next step would send this request to the Google NTP server. So which function should I use? Upper link socket.send should be named send. But there are two sends: send all, send to. Which one I should use? For send, it's just send data. Send to, I can specify server IP address. First thing, put IP data. Put data first. And then IP address and port number as a pair. Put a print function here for debugging. Now, wait for the response from the NTP server. This function should be very similar to the first function, which waits for client request. Put a print function here for debugging. Last step, send a response back to the client. This function, again, similar to the second function, but different thing is to use a downlink socket .send to and specify the client IP address we recorded in the first function. Put a print function here for debugging. because we are using socket to talk to remote machines, there might be cases which such as timeout or network unavailable, which could arrest some exception. We need to handle this. So let's use a try except structure to enclose the entire main loop. Let's how to catch exception in Python. Let's search how. In got its own GPT, but it doesn't look like the code I'm looking for. So let's use traditional search, and here should be some example. Here it is. Accept exception as error message E. Let's use this structure. And print out the error message to give us a clear idea what is happening. Okay, that's it. Let's try if my code could work as a first go. Debug as a Python file. Why not? Okay, let's put a breakpoint. Okay. Oh, what is happening? I think it is requesting Anaconda environment. Why is that? Maybe wrong compiler, wrong Python interpreter. Okay. This time it works. Let's close this. Oh, crashed. Let's put multiple breakpoints and go through it one by one. Okay, it's stuck here, so continue. Okay, it is waiting for the request, so let's use this software, NTP checker, to put a local host address 127.0.0.1 test. Okay, it passed through the first function. Let's go through the later one by one. What is received? Okay, go. Yeah, response is received, but I don't know how to interpret that. Okay, that's a IP address of Google NTP server. Continue. Okay, it's a loop back. Looks all good. Let's remove those checkpoints and let it run. This time, instead of using NTP checker, let's go to the embedded controller directly. Open SOPAS engineering tool. Open this controller control panel. Go to where was okay, system status. It's still running the old time. Let's go back to NTP setting and see what is happening. Where was that? I think it's in system. Where's the system folder? No, not protocol. Oh, okay, system. It is over here. Oh, it need to wait for 600 seconds for the next request. Let's just disable this and enable. It should send a request on this moment. Save this setting permanently and go back to system status. Okay, our program is running without a problem. It is showing the client embedded controller's IP address, so the request has been sent and the response is received. Bingo, here it is. The correct time is set. Next question, we are not going to run this Python script manually each time. So we need to make it executable automatically on startup. By using this trick, Python W and the script name. In this case, the program is started in background even after you close this command line window. Let's check with this NTP checker. Remember the localhost address. Okay, it is running, no problem. To terminate the Python W program in background, we need to use this command, task kill. Let's use a help function to figure out what's the parameters. We should use this F, force it to stop without ask yes or no, and IM to specify which program name we are going to close. I think that's it. Use those two. Clear the command line and task kill /f/im/ and no more slash Python W dot executable. Okay, you can see the background thread has been terminated. No, we don't have a admin access. Let's run this PowerShell as an admin, and then put task kill /f/im Python W .exe. Okay, this time it got success termination. Let's run this NTP checker again. If there's no response, we are closed. Okay, all good, no response. It means the NTP relay running on background has been terminated. I guess you don't want to run Python W command each time. So let's use Windows Task Scheduler. Right click on the Task Scheduler library and create a new trigger, which is on log on startup. Because sometimes the machine just start up, but no one log on. Let's put this command cmd/c and at, which means does not wait for the Python W to finish. Close the command line window immediately. Python W and C root directory NTP Relay.py. Let's try this command with Windows +R. Okay, it run, but there's a side effect. You have to manually close this window. If anyone knows how to get rid of this window, please let me know. It would be appreciated. /c, and let's try it again. This time it automatically closed, but I think it's because Python W is already running the exception causes it to close. Okay, let's paste this parameter into the parameter blank. Okay, I think it's done. Name this as NTP Relay Start. Okay, the next step is to restart the machine and test. Restart. Okay, you see this window. It means that command is executed. We just close this. Let's see 127.0.0.1. Okay, now it is working. Thank you.